Alright, this is homework 4. The first, let's get started with the first question. The first question is about a concierge service in a large resort. The question says the arrival rate is 12 guests per hour with the standard deviation of 5 minutes for the inter-arrival times. The hotel has only one concierge service on the concierge on service. That means we have to use the first thing, use the waiting time formula for one resource, right? Because there's only one concierge on service at any given time. Well, the first part, so what is the activity time? The activity time is the formula for one resource TQ is processing time P multiplied by utilization 1 minus utilization multiplied by CVA square plus CVP square, this whole thing divided by 2. Well, the first thing we need is P, right? Well, the first thing we need is P. So what is the P is the activity time. P is the activity time. How long does it take to serve one customer? That's what P is, right? That is, it takes the concierge on average 4 minutes to help the guest with their question. So we have the first thing, we have P equals to 4 minutes. Okay, we got that part. The second part is what we need: utilization. U is utilization. So utilization is nothing but flow rate divided by the capacity. Flow rate divided by capacity. Remember, in waiting time formula, flow rate is given by the demand. In this case, the demand is 12 guests per hour and the capacity is 15 guests per hour. Well, why is the capacity 15 guests per hour? Well, it takes 4 minutes to serve one customer. That means on average you can serve 15 guests per hour, right? This comes out to be 0.8, that is 80%, right? So the utilization is 80%. Okay, now we need CVA. So how do you get CVA? Well, CVA is nothing but the standard deviation of inter-arrival times divided by the average or the mean of inter-arrival times. Inter-arrival times. Well, what is the inter-arrival time? What is the standard deviation of the inter-arrival time? Well, that's given to us. The standard deviation of the inter-arrival times is 5 minutes. That's a straightforward number. What is the average inter-arrival times? Well, we know on average 12 customers arrive per hour, right? So if you know 12 customers arrive per hour, that is, let's suppose 1 here, 2 here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Altogether 12 customers arrived in this hour. That means the average gap between these two arrivals, what is inter-arrival time, has to be 5 minutes, because 12 multiplied by 5 is 60, right? That means the CVA equals to 1. What is CVP? Let me use a different color here again. CVP, again CVP is bad color. CVP is nothing but, again, the standard deviation of processing time divided by the average of processing time. Okay. Standard deviation of processing time divided by the average of processing time, or the mean of processing time. Well, let me use a little bit of space here. This is nothing but, again, standard deviation of processing time is given to you as 3 minutes. The standard deviation of it this time is 3 minutes, and it says the average processing time is 4 minutes. Right? That's what the number we calculated here. So 3 divided by 4 equals to 0.75. So we have the CVA equals to 1, we have CVP equals to 0.75. So we have all the numbers we needed. We know P, we know U, we know CVA, we know CVP. After that, it's just about putting it in the formula. Let me use more space here. So TQ equals to, we have the processing time equals to 4. We have U equals to 0.8. We have 1 minus U, so 0 minus 0.8. CVA equals to 1, so 1 square plus 0.75 square divided by 2. You can do all the calculation, and this comes out to be 12.5 minutes. That's all there is to it. Next, let's look at the next problem. So let me draw a line so that we know this is this part. This question says, how many guests will on average be at the concierge desk either talking to the concierge or waiting in the line? Remember, not only waiting at the line, but also talking to the concierge, both. And it doesn't have to be an integer. Well, we have to use Little's law. Use Little's law here, which says I inventory equals to R flow rate multiplied by time, that is flow time. Well, we know the flow rate, we know the flow time. Obviously the question is asking I, right? Inventory, number of customers, waiting, or talking to the concierge. So the flow time here is a little tricky. This is the time is the waiting time plus the processing time. Because remember, why do we add this both? Because it's either talking to the concierge or waiting on the line. So waiting on the line plus the processing time. Okay, after we have that, I equals to flow rate is 12 customers per hour, multiplied by this T is waiting time of 12.5 minutes, that's what you calculated, plus the processing time on average is 4, so altogether 16.5 minutes. But you cannot just write 16.5 here because this is in terms of hour. To convert this into hour, I divided by 60. Well, if you do this, this comes out to be 12 multiplied by 16 divided by 60 is 0.275. So we get 3.3 guests. So on average, there is 3.3 guests waiting at the line or talking to the concierge. That's all there is to the first question. Let's go to the second question. In this question, we have multiple servers. In this case, the restrooms, these portable toilets are the servers. It's kind of difficult to think of them as servers, but You can thank my creativity for that. Well, what is the average utilization? The first question is easy. Well, the average utilization when you have multiple servers. Remember, this has multiple servers. Again, you can use the same utilization is flow rate divided by capacity, but the simplified version of that, in this case, you can always think of this as PAM, P divided by AM, or another way to think of this, P is the activity time divided by A is inter-arrival time multiplied by number of servers. Well, activity time here is 4 minutes, right? On average, a person spends 4 minutes on the toilet. Inter-arrival time is a little tricky here. There are 2 arrivals per minute. Again, the same questions, 2 arrivals per minute. So if in 1 minute there are 2 arrivals, right? One arrival and the other arrival, on average there has to be 30 seconds of gap, right? Same thing to say 2 arrivals per minute or 1 arrival every 30 seconds. So this every 30 seconds is what the inter-arrival time is. So the inter-arrival time is 0.5 minutes multiplied by the number of servers is 10. So 4 divided by 5 is 80%. Well, the next question is, what is the expected time a customer will have to wait? Okay, that is again the TQ, but the formula is a little different here. Here we use the more comprehensive TQ formula for the multiple servers. Let me write it in terms of a word rather than just the symbols, so that you have something to refer to. P by M, or another way to think of it, is activity time divided by number of servers. Number of servers is M for multiple. Number of servers multiplied by U, in this U is utilization, but all these things powered to 2 multiplied by number of workers plus 1, and outside this root under 1, but this is all on the power, divide by 1 minus utilization, and again the third part is not changed, it's just CVA square, coefficient of variation of arrival square, plus CVP square divided by 2. Okay, well, the first thing again we need, we already calculated this utilization U. Activity time is obvious, takes 4 minutes for each person to get the service from the toilets, 4 minutes. Number of servers is 10, this part is easy. Let's go to the second part. The second part is fairly straightforward again. Utilization is 0.8, and on the power we have 2, number of workers 10 plus 1, and outside the root under minus 1, divide by 1 minus 0.8, power multiplied by the last part, CVA. So we need to calculate CVA. CVA is coefficient of variation of arrival. So here the standard deviation of arrival the standard deviation of arrival is 15 seconds. Standard deviation of arrival is 15 seconds. The mean of the arrival is 30 seconds because the inter-arrival time. The standard deviation of inter-arrival time is 15. The mean of the inter-arrival time is, given that there is 2 arrivals every minute, the gap between 2 successive arrivals on average is 30 seconds, making this 0.5. How about CVP? CVP is on average the average goes at the bottom, so on average it takes you 4 minutes to serve the customer, and the standard deviation is 1, so this is 0.25. Again, the mean goes at the bottom, standard deviation on the top. So now we have CVA square, that is 0.5 square plus 0.25 square divided by 2. This whole mess, if you solve it, again make sure you have to do 2 multiplied by this 10 plus 2, that is 2 multiplied by plus 1, 2 multiplied by 11. You take the square root of it and subtract 1 from it, and that is what you should. So basically you should do 4 divided by 10 multiplied by 0.8 power square root of 22 minus 1 divided by 0.8 multiplied by 0.5 square plus 0.25 square divided by 2. You do all this math, the answer comes out to be 0.137 minutes. I trust you can do that calculation yourself. How long will an average toilet be empty in a 5-hour concert? Well, this part is fairly straightforward, and in fact you should be able to do it very easily. So in 5 hours it's empty for 1 minus 0.8, because the utilization is 80%, that means it's free 20% of the time. 1 minus 0.8, which comes out to be 1 hour. So on average a toilet is empty on average the toilet is empty, each toilet is empty for an hour. Next question is what is it going to be the average number of people in the queue? Now the question is only in the queue, not using the toilet. Again, the same formula as before, I equals to R, RT, R is flow rate, T is flow time. So flow rate is 2 customers per minute. The flow time, again this is only at the queue, not the service time. The flow time is what you just calculated, 0.137 minutes. So this is both in minutes, right? This is minutes, customers per minute. Customers per minute. So 2 customers per minute multiplied by 0. Write this again. 2 customers per minute multiplied by 0.137 minute, and this comes out to be 0.274. So on average 0.274 customers are waiting on the line. Customers are waiting on the queue. Alright, that's all there is to the homework.